Hey everybody, let's look at an API first workflow for developing and testing gRPC microservices. So the teams will be starting with defining the gRPC services. So the producer team, the consumer team, and the architects will work closely together to define the gRPC services. So then the teams can go and work in parallel on their microservices. So the consumer team would create mocks of those gRPC services and develop and test in isolation their consumer microservice. And in the meantime, the producer team would be developing and testing their producer microservice. While they're doing that, it's important to remember they will be communicating any changes to those gRPC services so they stay in sync. Once both of those microservices have been developed, they would test the producer and the consumer microservices together. And once the testing is complete, you can release that to production. Let's zoom in on defining the gRPC services. How is that done? Well, as we said, the producer team, the consumer team, and the architect would work together to create the protobuf files that contain the definitions of those services, and then they would commit and push those protobuf files to a Git repository. How would the creation of the gRPC service mocks look like? Well, you start with checking out the projects with those protobuf files we've just created. Start a API gRPC mocking tool like Traffic Parrot on the developer's laptop locally. Use Traffic Parrot skeletons to create mocks based on those protobuf files. Commit those mocks to Git and stop Traffic Parrot. And you've got the mocks created and they're checked in and pushed into your Git repository. Then the pipeline will pick those mocks up and create a Docker image with Traffic Parrot and those mocks and push that Docker image to the Docker registry. How would development and testing of the consumer microservice look like? Well, the developers would start with starting up Traffic Parrot mocks locally, and then they could continue to start their microservice and develop and test it locally. Once they've done the development and testing on the laptop, they can push that code to GitHub, or any other pipeline you're using would pick that up, build the artifacts, and then the QAs could do some manual exploratory testing, for example, locally or in shared environments. How does the CICD pipeline workflow look like if we zoom in just on that bit? Well, let's say we're using GitHub Actions. So typically you're going to be checking out the microservices project. You start the mocks as a Docker container. You start the microservice as a Docker container. You can run your tests against the microservice in isolation because the mocks are provided by Traffic Parrot here. And once that artifact has been built and validated, you can push it into the repository of your artifacts. How would communicating changes look like? Well, some of our customers use this workflow, and it's communicating changes using Git pull requests. So let's say the producer team needs to make a change to the service definition. They will check out the project, make changes to the protobuf files, create a pull request, and then the consumer team and the producer team can work closely together, commenting on the changes, making sure everybody's fine with the proposed changes, and then the PR gets merged, and the protobuf files can be then consumed on the consumer side in that project. Once we've tested the microservices in isolation, then it's time to testing them together. How would that look like? Well, you're starting one microservice, you're starting the second one, and you test them together. Okay. Once they've been tested, you can promote the artifacts and they'll be ready for release. Let's have a look at how we could do that with Traffic Parrot gRPC mocks. Okay. So we've got this repository here. And this repository is a monorepo, so it contains the client microservice, the server microservice, and the order service definitions, the ones that contain the protobuf file, and some Traffic Parrot files. Okay, so what we're going to be doing first, once we've checked out the project, we're going to start Traffic Parrot on the developer's laptop, my laptop, and again, this is we're talking about creating the gRPC mocks with Traffic Parrot. We're zooming in on that bit of this workflow. So we've checked out the project. Let's start Traffic Parrot locally. So I've got Traffic Parrot downloaded here. I can just extract it and start it up. there we go, traffic pilot's running, and we can open the web user interface and go to gRPC add edit. We can import the proto file. There we go, traffic's imported it, and we can use this skeleton feature which recognizes that there's this order purchase service, and it pre-populates the sample request and response for us, so it's much faster to create those mocks. So we can say that for this gRPC method, whenever we receive requests for SKU1 and quantity 1, we're going to return a response or mocked response that's going to say ordered 1 item. Save that, and there we go, we've got this mock created here. So what happens next? Well, we've created the mocks using the skeletons feature of Traffic Parrot. We can commit them to Git and stop Traffic Parrot. So let's commit them to Git now. So we're going to put them in the Traffic Parrot folder in our monorepo. And where do we get them from? Well, they're in the Traffic Parrot gRPC mappings folder. And if I show you what the file looks like, so this is the mapping that you saw on the user interface. It's got the request section, the response section, quite human readable, and you can version control it as well. So let's go ahead and copy this directory to the Git repository, commit that, and check it in. There we go, we've pushed the mocks, and we can stop Traffic Parrot now. And now that this action has finished, we can see that the Docker image has been pushed to the Traffic Parrot Docker repository. So now that the Docker image has been pushed to the remote repository, we can pretend to enter this workflow on the right, which is developing and testing the microservice locally. So I'm going to pretend to be the consumer team developer, and I'm going to start Traffic Parrot locally by using the image that's just been built by GitHub Actions for me, and I'm going to pretend to be developing and testing a microservice in isolation with those mocks. So first of all, open a new tab here and run my Docker image. And as far as I remember, that build number was 6, so we'll start number 6. There we go, we got Traffic Parrot running inside a Docker container locally. Let's have a look at it, and there it is. This is the mock that we've created manually, or somebody else has created for us manually a few minutes ago, and we can now use it because we've got the Docker image, the Docker container running locally, and we can develop our microservice and test against this mock that pretends to be the producer microservice, which is the backend microservice. So now that I've started Traffic Parrot locally and it's running in this Docker container that's been built by my GitHub action, I can develop my microservice and rely on those mocks to pretend to be or simulate that backend microservice, that API or service producer microservice. Okay, so let's assume I've been coding for a day or two already and I've got that microservice running. So I've got it actually working here, so you don't have to watch me code. There's my microservice. I can just start it up. And just for simplicity, this is a Swing application with a user interface. So we're not actually having a real microservice, but a service with a user interface, just for the simplicity of this demo. But bear with me. So we know Traffic Parrot gRPC port is on 5552 and it's running on localhost. That's where we're testing right now. So I've developed this application over the last day or two, and I'm trying to test it. Does it actually work, right? And can I communicate with a real shopping application server? But the shopping application server is not present yet. The team hasn't finished developing it yet. So I'm using Traffic Parrot mocks to pretend to be that shopping application server. And I've started Traffic Parrot within that Docker container, and it's running on localhost 5552. Okay, so I'll press order, and there we go. We got the message that says ordered 1 items of type SKU1, which is what we've configured Traffic Parrot to do here. Okay, so what we've done now is we were able to test our development effort that I've done over the last 1 or 2 days, and in isolation because I've used the gRPC service mocks. And once the let's go back to that slide at the very beginning. Once the producer team finishes their the producer microservice, we can test them together. So I can also show you how to make this mock a bit smarter. So let's have a look at that. So I could say right now, you could see that this is hard-coded SKU and quantity value to 1. So it doesn't matter what I put in here, traffic part's coming back with errors. Why is that? If you read those messages carefully, you're going to see that it can't find a mock for this item ID and this quantity. Why is that? Well, because we've hard-coded it here to these values. So how do we fix that? We go to trafficpilot.com, documentation. We look at request matchers, because that's what that error message told us to look at. And we go to gRPC, and I'm just demonstrating how good our documentation here is for you. And we go to request matchers, and we'll see that we can use this fancy matcher called matches JSON representation, and we can match any values for the values of those attributes that come in the request. Okay, so what I'm going to do is use this any number matcher in our mock here, like this, and I'm going to use matches representation. So now when I save this and clear this up, I'm getting responses, right? But the response still says ordered 1 item of type SKU1. Why is that? Well, because it's hard-coded here to just that. So how do I make this dynamic? We could take the request data that just came in and put it back into the response. How do we do that? We go to documentation, dynamic responses. We want to generate the response dynamically. And what we'll see here is that we can use this handlebars notation to generate random numbers, etc., etc. But what we're looking for is using request data and responses. And for gRPC, we have access to this thing called request body. So we're going to use that. So I'll use request body in here. But what I need is part of the request body. So how do I extract the SKU and quantity? I can use the handlebars helper called JSON path. And how does JSON path work? So I can just use something like this. And this will allow me to access parts of the request body and generate. I'm using JSON path to access the request body, and what I need is quantity and SKU in here. Save that. And now if I press order, suddenly this traffic pad mock behaves almost like the real microservice, because I'm getting back in the responses what I have put in the request. Okay, so yeah, so this was a very simplistic example. Hopefully it gives you an idea of how you could use traffic pad mocks to simulate or mock backend microservices, and hence allow you to parallelize work between teams and work in this API first fashion for gRPC services. Thank you so much for watching, and go to trafficpilot.com, click on the trial at the top to be able to download the evaluation version of our software, and looking forward to hearing from you. Thanks, bye-bye.